Fun-PGA. This is Naz, and today I'm excited to show you a project I recently finished. Yes, a color-based tracking system running entirely on an FPGA. So let's get started to see how it works. To demonstrate how this tracking system works, I created a simple flight radar animation. In this demo, there are 8 planes, each with a different color, moving across the screen. The tracking system can follow any of these planes based on the color you select. You can render anything you want and send the 24-bit RGB video data to the color tracking system. It works with any shapes or objects. The tracking system is capable of tracking 12 main color shades. To choose which color you want to track, you use 4 switches on the board. For example, if all 4 switches are low, 0, 0, 0, 0, the system tracks yellow color. If the 3 left switches are low and the rightmost switch is high, 0, 0, 0, 1, the system tracks cyan color. Based on the color you want to track, set the switches to the correct value and enable the tracking system. After that, the tracker finds the object with the selected color and draws a bounding box around it. The tracker also displays the center coordinates of the object on the screen. If the selected color does not appear anywhere on the screen, the system cannot find any object. In that case, it displays "Not Found" on the top of the screen. So that was a quick demo of the color tracking system. Now let's dive into the details and see how this tracking is actually implemented inside the FPGA. The tracking system uses a 4-stage video processing pipeline. First, the color classifier filters the raw incoming video. This module acts as the eyes of the system. It receives 24-bit RGB data and classifies each pixel into one of the 12 main color shades by checking the strengths of each channel. For example, let's assume we want to track the color yellow. In this case, the classifier looks for a tight gap between the strong red and green values. If the blue channel is extremely weak, the system confirms that it has found a yellow pixel. But detecting the color is only the first step. Next, the tracker engine scans those pixels frame by frame. It records the absolute outer limits where yellow appears, establishing a physical bounding box. Once the boundary is set, the system draws a precise crosshair over the target. To make the target stand out, it washes all ignored background pixels with a solid green filter. Finally, the tracker calculates the exact center of bounding box as a string of raw binary code. To convert those unreadable 0 and 1s into standard decimal coordinates, an algorithm called double-double is used. So, in this way, the FPGA instantly transforms the video feed into real-time tracking data. A quick thing before finishing this video, I just wanted to mention that if you are interested in recreating this project, you will find the source code in my GitHub repository. Also, you will find the link of my GitHub repository in the caption of this video, so feel free to check that. And a big thank you for watching this video, and I will see you next time with another project. Bye bye!